Hello and welcome to another session in mathematics. In this session we'll be looking at mean and standard deviation. But before we go on, let us take a review of our previous lessons. Welcome back. Our focus in this study will be on mean deviation and then standard deviation. Okay, I will start by giving us the formula for finding mean. I know we are conversant with that. Mean, or written as x bar, is equal to summation of fx all over summation of f, read as sigma fx over sigma f. And then for standard deviation, which is SD, we have it to be the square root of sigma f into x minus x bar squared all over sigma f. Okay, or we use SD to be equal to square root of sigma f into x minus a squared. Okay, this is all over sigma f minus sigma f into x minus a all over sigma f all squared. We use this when solving with assumed mean. Assumed mean, standard deviation. When we use assumed mean, standard deviation, then we use this second formula. But when solving for ordinary standard deviation, we use this. Okay, now here a in this second formula is the assumed mean. Assumed mean. Okay, we'll deal with the both of them, how to use these both formulas. Okay, so let's take an example. We have an example here on the screen. So the table below shows the distribution of weights of group of 50 students in a class, and we have the class intervals and the frequency written here on the screen. The question said we should calculate the mean, that's one, and then 2, standard deviation correct to 1 decimal place. Find the mean and then the standard deviation correct to what? 1 decimal place. Okay, so we will start with our method 1. Our method 1, let's call it method 1. In this method 1, we will use class mark to find mean. Okay, we use class mark to find mean. So let us start with our table. Okay, we have the class interval. That's the first thing. This is the class interval. This is the frequency. We have the class mark. We have f. This class mark is our x. We have f times x. We have x minus x bar. We have x minus x bar squared, and then we have f x minus x bar squared as our last. Okay, for our class interval, let's go back to the question. We have 45 to 49, 50 to 54, and so on and so forth. So let's write it down. We have 45 to 49, we have 50 to 54. We have 55 to 59. We have 60 to 64. We have 65 to 69. We have 70 to 74, and that's the last. Under our frequency, we have the first one to be 6. We have the second one to be 9. This is 10. We have here to be 12. We have here to be 7, and here is 6. Okay, our class mark. How do we determine our class mark? Our class mark means 45 plus 49 divided by 2. That is finding the class mark of the first class interval here, which is this. We have 45 plus 49 divided by what? By 2. Okay, and that will give us what? 47. So this is 47. Do the same here. 50 plus 54, 104 divided by 2. What will it give you? 52. 55 plus 59 divided by 2. What do you have? We have 57. Okay, do the rest. We have 57, we have 62, we have 67, and then we have the last one to be 72. Okay, so let's go over to fx. Fx means a frequency times our class mark. So 6 times 47, what would that give us? 282. We have 9 times 52, and that will give us 468. We have 10 times 57, we have 570. We have 12 times 62. 12 times 62 will give us 744. 7 times 67 will give us 469. And then we'll have the last one, 6 times 72, which is 432. 432. Then we have x minus x bar. What's our x bar? Our x bar is our mean. Our x bar is our mean. How do we now determine the mean? Let's go over to the next page. I told us that mean is equal to, which is s bar, is equal to summation of fx all over summation of what? F. What's the summation of fx? This is fx. Summation of fx is add up the numbers here. Let's do that. Let's do that together. 282 plus 468 till you get to 432. We have 2965. 2965 as the summation of what? Fx. Then we'll find the summation of what? F. We'll add everything under this column, and what do we have? We have 50. So we have 2965 all over 50. Okay, and then divide this. What do we have? We have an answer to be what? 59.3 kilogram. That's the value of what? Our mean. So let's go back. We have our answer to be what? 59.3. So we now have x minus what? X bar. X minus what? X bar. So this is our x. 47 minus what? 59.3, and that will give us minus 12.3. Is that correct? Okay, then we'll have the next one. 52 minus 59.3 will give us what? Minus 7.3. We'll have a 57 minus 59. 57 minus 59 will give us minus 2.3. Okay, we'll have 62 minus 59. That will give us 2.7. We'll have 67 minus 59. 67 minus 59 to give us 7.7. Then lastly, we have 72 minus 59.3, and that will give us 12.7. We have x minus x bar squared. That is the square of these ones. The square of this one. So we have minus 12.3 raised to power 2. Minus 12.3 times minus 12.3, and that will give us our answer to be 151.30. Okay, minus 7.3 squared will give us 53.29. Minus 2.3 squared will give us 5.29. 2.7 squared will give us 7.29. 7.7 squared will give us 59.29, and then we have 12.7 squared to give us 161.30. Okay, now we've gotten x minus x bar squared. We are now to find the value of f into x minus x bar squared. What does that mean? It means f, which is our frequency here, times these ones. Okay, so we have 151.30 times 6. Okay, 6 times 151.30. What do we have? We have 907.80. Okay, we have 9 times 53.29 to give us 479.61. Okay, we have 10 times 5.29, and that will give us what? 52.90. We have 12 times 7.29, and that will give us 87.48. We have 7 times 59.29. We have 415.03. And lastly, we have 6 times 161.30 to give us 967.80. And the total of this will give us summation of f x minus x bar squared, and that will give us 2910.62. okay, and this is our sigma fx. This is our sigma f. Okay, we've got to now these values. So let us now apply the standard deviation. I gave us the formula of standard deviation to be equal to SD equal to square root of sigma f into x minus x bar squared all over sigma f. Okay, so f into x minus x bar squared, what's the value? This is the value, 2910.62. we have square root of 2910.62. okay, and the value of sigma f is 50 all over 50. okay, and that will give us 7.6 kg. okay, so we've gotten the values of the mean to be 59.3 kg and the value of the standard deviation to be 7.6. and I told us there is another way of finding the value of the standard deviation using what we call what? Assumed mean. Assumed mean. So let us consider the assumed mean. Let's go back to the table. Now let's assume that our mean is 62. Remember what mean is? Remember how we determine mean initially? Mean is was determined as addition of all the numbers divided by 2. Addition of all the numbers divided by what? By 2. So let's assume that 62 here is our mean. Okay, this is x. So if 62 is our mean, then a is equal to what? 62. I told us that our assumed mean is denoted by what? A. I gave us the formula here, so this is the formula, you remember? Yeah, so let's carry it over to the other side. We have SD, which is a standard deviation, to be equal to square root of sigma f into x minus a all squared all over sigma f minus open the bracket, sigma f into x minus a, then all over sigma f all squared. Okay, now with this we still need to form a table to be able to derive x minus a and x minus a squared. Okay, so let's go over to the next page and draw a table. We have class interval, just like the previous table. We have the class interval, which is 45 to 49, 50 to 54, 55 to 59, 60 to 64, 65 to 69, and then 70 to 74. Okay, now we have a frequency which is f. Under f we have here to be 6, we have here to be 9, this is 10, this is 12, this is 7, and this is 6, and the total is what? Is 50. Sigma f is 50. And then the next thing we need to find is our class mark. A class mark, which is our x. Okay, you know how we do that, right? So this is 45 plus 49 divided by 2. We have 47. We've done that before. We have 52, so I'll be rushing. Okay, we have 57, we have 62, we have 67, and then we have lastly 72. Okay, the next thing we need to determine is x minus a. X minus a. X minus a. So what's our a? Our a is what? The assumed mean. Assumed mean, which is what? 62. A is 62. Is that correct? Assumed mean. So our assumed mean, we then have 47 minus 62, and that will give us minus 15. We have 52 minus 62, and that will give us minus 10. We have 57 minus 62, and that will give us minus 5. We have 62 minus 62, that will give us 0. 67 minus 62 will give us 5. 72 minus 62 will give us 10. Okay, then the next thing we have f into x minus a, that is frequency times this. So have 6 times 15, which will give us 90. Because of the negatives, I have minus 90. 9 times minus 10 will give us minus what? 90 also. And 10 times 5 will give us minus 50. 12 times 0 will give us 0. 7 times 5 will give us 35. 6 times 10 will give us what? 60. And we add it up to get sigma summation of f into x minus a, and that will give us our value to be, add them up, we have minus 135. Okay, then we have x minus a squared. X minus a squared. So this is x minus a. Now squared, that means minus 15 squared, and that will give us what? 225. Minus 10 squared will give us 100. Minus 5 squared is 25. 0 squared is 0. 5 squared is 25. And then 10 squared is 100. Then lastly we have f into x minus a squared. Okay, so that means f times all this. 6 times 225 will give us what? 1350. 9 times 10, 9 times 100 will give us 900. 10 times 25 will give us 250. 12 times 0 is 0, and 7 times 25 is equal to what? 175. 6 times 100 will give us what? 600. And then when you add it up, we then have the summation of f into x minus a all squared. Add everything up, we have 3000 275. So we've gotten the values required for this solution. Okay, so our SD will then give us the square root of sigma f x minus a or squared is equal to what? 3,275. 3,275 all over sigma f. What's our sigma f? 50. We have here to be 50. Then minus summation of f into x minus a, open a bracket. We have this, and this is minus what? 135 minus 135 all over summation of f, which is 50, or squared. Is that correct? Okay, so we'll break this down. Then this is 3,275 divided by 50, and that will give us the square root of 65.5 minus, open a bracket, minus 35 divided by 50 will give us minus 2.7. Minus 2.7. Remember, there is a square here. You add your square. Okay, and this will then lead us to having 65.5 minus 2.5 squared minus 2.7 squared will give us 7.29, and 65.5 minus 7.29 will give us square root of 58.21. And then when you take the square root of 58.21, you have your answer to be 7.629 kg. Leaving our answer in 1 decimal place, we then have it to be 7.6 kg. 1 decimal place. Okay, 7.6 kg. What did we get initially? When after solving for this, we got it to be what? 7.6 kg. You see, so you can use either of the ways to solve standard deviation and still arrive at the same answer. So to refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to deal with standard deviation. We'll stop here for today, then our next class will continue. So do well to use the lesson note on the platform for better information and understanding of what we've just done today, and feel free to leave a comment or question on the comment section if you have any. Till we meet again in the next class, stay safe and bye.